So let's do an initial value problem that's a little bit more involved. This one is going to require a few different steps rather than being able to do it all in one step like we did with the previous one. So here's what we're given. We're given that d squared y over dx squared is equal to 6x. dy over dx, and by the way, recall that d squared y over dx squared is just another way of writing the second derivative when y is a function of x, and I'll show you how in a minute how we'll deal with that. Dy over dx is equal to 17, but I'm not saying it's the constant function 17. I'm saying that it's going to be some function of x, and when I plug in x equals 2, I'm going to get the number 17. Similarly, I know that y equals 7 when x equals 1. So again, I'm not saying that y is the constant function 7. I'm just saying that y is going to be some function of x, and when I plug in x equals 1, I'm going to get 7. So I'm being asked to find y. The first thing I like to do when I see this is to translate it into the easier notation. In fact, the only reason I've written it in this notation is because there are some textbook and MyLab problems that write the problem in this notation. So this is the way that I'm going to do it. I'm just going to translate it into the sort of easier notation. We're given that f double prime of x equals 6x. We're also given that f prime of 2 equals 17. Stare at this expression for a minute and make sure you agree that what this is saying is, when I say that the derivative is 17 at x equals 2, what I'm saying is f prime of 2 equals 17. And similarly, I'm saying that f of 1 is equal to 7. So this is purple line here is kind of my translation of the 3 bullet points. The textbook may give it to you in this form. I think it's sort of easier to imagine it in this form, and I'm going to proceed from using whatever in purple. So the first thing to observe is that f prime of x is equal to the indefinite integral of f double prime of x dx. This is simply restating the relationship. We know that f double prime is the derivative of f prime, therefore it makes sense to say that f prime is an antiderivative of f double prime. That's just the reverse of the relationship between them. So what that means is that f prime of x is equal to the antiderivative, the indefinite integral of 6x. So that means that that's going to equal 3x squared plus c. So I know that whatever f prime is, it's going to be 3x squared plus some constant. I just have to solve for that constant. Well, here's what I'm given about f prime. I'm given that f prime of 2 equals 17. So that means that f prime of 2 must equal 3 times 2 squared, I'm just replacing the x with a 2, plus c. And that has to equal 17. Well, 3 times 2 squared is 4, so that's going to be 12 plus c equals 17, and we can readily see that c is equal to 5. So that's, okay, so I've found that c is 5. What does that tell me? What that tells me is that f prime of x is now no longer just some unspecified function, because I know now exactly what c is because I've solved for it. So f prime of x is equal to 3x squared plus 5. That's f prime. What the question is asking me for is, originally it was y, and since I've sort of changed that into f, what I'm really changing this to is find f of x. So what we want to do is we want to now go from f prime to finding f. Well, we know that f of x is equal to the antiderivative of f prime of x dx. And again, I'm just restating what we know about derivatives. F prime is the derivative of f, therefore f is an antiderivative of f prime. So that means that f of x is equal to the indefinite integral of 3x squared plus 5 dx. That's equal to x cubed plus 5x, and I'm going to use a different constant here because I've already used c. I'm going to call it d. So we know that whatever f of x is, it's going to look like this. It's going to be x cubed plus 5x plus some constant that we'll have to solve for. Look what we're given. We're given f of 1 equals 7. So f of 1 is equal to 1 cubed plus 5 times 1 plus d, and we know that that has to equal 7. So focusing on this part of the equation, we have 1 plus 5 is 6 plus d is 7. So if 6 plus d equals 7, and that gives me d equals 1. Therefore, I now know what f is because I know exactly what d is. So the answer is f of x is equal to x cubed plus 5x plus 1. And since the question actually asked for us to find y, I suppose I can finally just enter y equals x cubed plus 5x plus 1. And that's fine. It's sort of easier if the problem is actually given in this form, but you can just translate it into a problem involving f instead of the Leibniz notation if you find it easier.